Hey, Miss Sparks.
Hey, Adriana, how are you?
Doing good. How are you?
Good.
Good, good.
Do you have specific questions or just
No.
coming to see something today?
Yeah, that's basically it.
Okay. So nothing specific. Would you rather work on the book work or the worksheet?
Um, are either of them due tomorrow? Because whichever one is due, I'd like to work on.
I was just going to have y'all put all of your work in the unit circle folder and take it up at the very end. I
Oh,
might just look to see if how far y'all got on it to
mhm.
see how you're doing. You know what I'm
Okay.
saying? Just to see if there's an area that you're struggling with. But
Okay.
if there's not an area that you're struggling with, I'm not going to worry about it too awful much. Does that make sense?
Yes, ma'am. Um,
So,
okay. Well, I haven't started the book work yet. I was working on the worksheet, so
would you like to just keep working with that? The
sure.
book work is a lot like the worksheet, honestly.
Okay. We
It's
can keep
just that
working.
was a way for me to be able to introduce it in class.
Mm-hmm.
You know what I'm saying? And then to give y'all extra practice because really just practice is what it takes, unfortunately.
Okay. Just so you know. Oh, wait. 1 second.
Okay.
Okay, I'm sorry.
That's okay. Not a
Um,
problem.
yeah, if you hear my dog and my family in the background, I lost my earbuds, so
Oh, no worries.
okay.
No worries. I understand perfectly. My family might be speaking in the background as well.
I can just go somewhere else. That would probably be smart of me. I'll just do that. Because I'm in the kitchen, which is where everyone is all the time, so
Me too. I'm in the kitchen.
funny, funny.
Fun, fun.
Okay. I think we're good now.
Okay. And I think I'll pull up the worksheet. So
Okay.
hold on just 1 second. Can you see it?
Yes, ma'am.
Okay.
Yeah, it was gonna be all girls.
All right. Did you get through the first part
Um,
or were you stuck on number 4 by chance?
well, I had to go back and rewatch that part of the video just
Uh-huh.
now. So
Yes.
I got it, but I'm not sure if I'm right. I could be completely wrong.
Okay. With regard to the video, did they have you convert to degrees or just kind of do an estimate?
I think they had us convert to degrees. You'd think I could remember since I did this literally 5 minutes ago.
Well, the only thing I was going to say, when you can't find the Lord, please help me. When you cannot find like number 5 is 5 pi over 3. You already know that that's a measurement on the unit circle. So that one's pretty easy. You know what I'm saying?
Right.
Because that's the equivalent of 300 degrees. That's kind of one of the benefits of memorizing the unit circle, you
Mm-hmm.
know? And then so that's 300 degrees. So all you're going to do on that particular one, I guess for the ones that you don't, that you wouldn't know quickly.
Mm-hmm.
Okay, oops. I thought I was writing and I wasn't. But number 5,
Mm-hmm.
and please forgive my writing. If we thought it was bad before, it's really going to be kind of a little sketchy right here.
Don't worry, it's all good.
That's 5 pi over 3, which is also 300 degrees. But we know that from memorizing the unit circle. Does that make sense?
Yes, ma'am.
Okay. So, so that one was kind of, that one was pretty easy. This one right here, there's a couple ways that you can kind of think about it. Number one, I know it's negative, so I'm going to go clockwise. So, and I'm not going to go very far, because when I think about it, when I'm going clockwise, the very first hit that I'm going to make is going to be pi over 6, which basically we know in our heads that's, 3.14 over 6. If you were going counterclockwise. Does that make sense on the unit circle? Am I tracking or not really?
Can you explain it one more time?
Okay. Well, I'm just saying, if we were going, and maybe this isn't a good way for you to think about it, but if you were going in a clockwise fashion, counterclockwise fashion, the first degree that we hit on the unit circle is pi over 6 or 30 degrees. Right. Does that make sense?
Yes, ma'am.
Now, like on the unit circle, if you were going in a counterclockwise, like going this way. Okay. So I guess what I'm trying to say is that I know that pi over 18 is much smaller than pi over 6. So I know it's not going to be quite 30 degrees. So since they're not really looking for an exact thing, I know I'm going to go in a negative direction and not very far. Does that make sense?
Is it okay if I did the little canceling thing to find exactly?
That is absolutely fine. This is more of an estimate anyway. Your way is much more exact, which is perfect. So if you did it this way, where you're doing the 180, which is actually pretty easy because this is going to cancel over the pi, which is, I'm assuming, what you did. Is that correct? So then that would cancel just like that. And then this would give you 10. So it's actually 10 degrees, except my writing is really bad. So so in all honesty, it's even smaller than what I guesstimated. So you probably did really good. So it would, but oh, look at that squiggly. Oh, that's just so bad.
It's okay. We'll blame it on spring break.
Well, I can hold a shift key down, but anyway, we'll just pretend like that was 10 degrees. It was better. I think I can hold the shift key down and write. So, but anyway, it's a 10-degree angle, but it's going in the negative direction. So, you're starting this way and going down. Okay. Does that make sense?
Yes, ma'am.
Okay. All right. Is that what you got? And you got number 5 as well?
Yes, ma'am.
I just assumed, and that's probably not a good idea. I assumed that you got 1 through 3 and you were okay on those. And I didn't even ask if you had questions, and I apologize. Do you have?
I see how it is.
I'm sorry?
I said, I see how it is.
Yeah. Well, you know what? You were good with this in class yesterday. So I didn't even think to ask. So I'm very sorry.
No, it's totally fine. I actually, like 5 minutes before the video, I was like, I should probably try this on my own, because in all honesty, you were right. So you were right. I was confused until about 5 minutes before you set up the video.
Oh, okay. All right.
So you were correct in your assumptions.
Okay. All right. Well, so if you need me for 1 through 3, I'll go back and do them.
Oh no, that's all good.
Okay. I was like, oh, I feel pretty certain about you.
No, it's all good.
I believe in you.
Thanks, Miss Sparks.
For 6 through 10. We're supposed to find a positive and a negative coterminal angle for these. So I
did the first 3.
You did the first 3?
Yes, ma'am.
Perfect. The other thing. Okay. The other thing that you technically can do is think about, instead of 360, What is the equivalent of 360 on the unit circle?
0
Or
or I don't know.
2 pi?
Oh, yes, that makes more sense.
Okay. Because I was going to say, we start at 0, come all the way around to 360. And with radians, we start at 0 and come all the way around to 2 pi. So I'm going to show you, you could do this one of two ways. You could go ahead and convert it to degrees if you wanted to.
Mhm.
Or the other thing that you could do is add 2 pi. Does that make sense?
Yes.
Okay. So in order to
go ahead
add
and
2
convert it.
pi to this, you'd have to get a common denominator. So that's going to give me 3 pi over 4 plus 8 pi. Oops. Pi. I can write. We do need to blame it on spring break. That would be 11 pi over 4. Does that make sense?
Yes, ma'am.
So what we're doing is just taking the equivalent of 360 degrees is equal to 2 pi, basically in radians. I'm going to just write rad if that's okay with you. So 360 degrees is 2 pi rad. So your positive angle, I'm trying to get rid of something on my screen, sorry.
It's okay.
So your positive angle is 11 pi over 4. Now, to do the same exact thing, you would take the 3 pi and subtract the 2 pi over 1, or subtract. So we'll take 3 pi, and we figured out for this particular one, we're just going to subtract 8 pi over 4, which would give us negative 5 pi over 4. So this is my positive answer, and this is my negative answer.
Okay, question.
Yes, ma'am.
It's okay if we just do it in degrees though, right?
Yes.
Because that's what I had done.
Okay. I will accept that, but I do hope that you'll gravitate out and learn to be more comfortable working with radians, because that's part of it. But I would accept it if you did it that way, because I know it's a lot of work to convert it to radians too. What did you get by chance?
I got 480 and negative 240.
Okay. All right. I hadn't worked them out that way yet. So, but I'm going to assume that you did, but you did them correctly. But I was going to say, it's kind of cool because 9 and 10,
Mm-hmm.
now that I worked them this way, if I add 8 pi to this over 4, I'm going to get 5 pi over 4 for my positive angle. And then I'm just going to get a negative 11 pi over 4 for my. So the good news for this one is that 9 and 10 were so close to each other.
This is probably a really stupid question, but why are you adding 8 pi over 4 again? Like, where'd you get that from?
Oh, okay. It's not a stupid question. It's a great question. All right. I'm going to erase some of this and kind of start over. Since you approached it from a different angle, I'm going to just kind of explain it again. Okay. So
Sorry.
no, these are all great questions. And if I'm asking you to get comfortable with working with the radians, then I would rather just re-explain it.
Mm-hmm.
You understand the concept clearly because you were good with 6, 7, and 8. You understood the concept clearly that in order to get a positive and negative coterminal angle, that you add 360,
Mm-hmm.
or to get the positive one, or subtract 360 to get your negative one.
Mm-hmm.
So here I would have what, 250? Is that right?
Yes.
No, 270.
Yes, 270.
270, and here I would have negative 450. Hopefully I did that right.
You did.
Okay.
Unless we're both wrong.
So I've got my positive and my negative. When I'm doing radians, I have to add a positive 2 pi radian. So I'm adding a 2 pi to my radian because this is my radian measurement, this right here. And in order to add 2 pi to negative 3 pi over 4, this really is the 2 pi over 1 is the same thing as 2 pi. Agreed?
Yes, ma'am.
Okay. So I have to have a common denominator. So I have to change 2 pi over 1 to be 8 pi over 4 because that is the equivalent of 2 pi with 4 as the denominator. Does that make sense?
Yes, ma'am.
Okay. So now I have negative 5 pi over 4. That's my negative. Oh, no. Yeah. No, that's my pi. I'm sorry. I've got positive 5 pi over 4. So that's my positive coterminal angle measured in radians.
Okay.
Okay. Does that make sense?
Yes, ma'am.
Okay. And so now what I would do, once again, I'm going to subtract 2 pi from negative 3 pi over 4. But since I already know that 8 pi over 4 is the equivalent, I would just do this. Since I know that 8 pi over 4 is the equivalent of 2 pi, then I would have negative 11 pi over 4.
Okay, I see.
It's kind of like, to me, I don't know if this is a good analogy or a poor analogy. For most Americans, we're so used to saying 3 inches or 2 inches, measuring something in inches and feet that we just automatically get it. But if somebody starts measuring in centimeters and millimeters and stuff like that, or meters, like if somebody were to give us a meter stick, it would be very difficult for us to kind of work with. So I feel like that is measuring in radians is the equivalent of just slapping down centimeters on us sometimes. You know what I mean? Because we're just not used to doing it. Plus, it's a little more cumbersome because of the fractions.
Yes.
It's weird. Fractions never leave us.
Oh.
They never go away.
Yay.
Yay. So, but that's really I would definitely say for numbers 1 through 5, like the number 4 and number 5, except for 5 was pretty easy because it was absolutely a radian on the unit circle. A lot of times if you're given those types of problems, I can almost see why a student would want to convert those to degrees, but it's very good like 6 through 10 to be able to state a positive and negative coterminal in the given measurement. Does that make sense?
Yes, ma'am.
Okay. It'll be dealing with fractions, and I know that fractions just are not user friendly, but any more questions about those?
No, ma'am. I think I'm good.
Okay. And if you wanted to convert to degrees, I'll definitely have to make sure that if you were to do that on your homework, I'd be okay. But on the test, we want you to be able to give the radians.
Okay.
Positive and negative. So practice.
Yes, ma'am.
Okay, converting each degree measure into radians and each radian measure into degrees. So what we want to do here is make sure that whatever you're canceling, whatever you want to cancel, because obviously this measurement given on number 11 is in radians. So you want your radians to be at the bottom. So you use whatever proportion you need to, in order to cancel. Does that make sense?
Yes, ma'am.
So in this particular case, our pi will cancel. And then we can cancel the 9. It's going to go in there one time. And then this is going to be 20.
Mm-hmm.
And then 20 times 13 is 260.
Okay, that's what I got.
Yay. Fun. So on this one, the appropriate measurement that you would use here, since we want degrees to cancel, we would want degrees on the bottom. Does that make sense?
Mm-hmm.
So I haven't worked these out yet. So
Oh, it's all good.
So our degrees, this little thing is going to cancel. So E, what will go into both of those? We know 5 will.
Yeah, if you divide it by, you can divide it by 3 and then divide it by 5.
Oh, you can? So 15 will go into both of them.
Yes, I think so.
Bless you. Yes. So 15 will go into both of them. This will be 11, and that's 12. So it's going to be 11. Oh, I do that every time. 11 pi over 12.
Okay.
Okay, so you tell me on this next one, what will we multiply? What will go in the bottom? What proportion are we going to use? I guess maybe that's the best way to say it.
You do pi over 180.
Good job. So the degrees will cancel.
And you can 10 goes into both of them.
Yes. Oh, good job. So it's going to be 13 pi over 18.
Mm-hmm.
Good job. You've got these. You don't even need me.
I'm not sure.
You're doing great. You're doing great. And this is really all the homework is that's in the textbook as well. Okay. It's just that we understand these require a lot of practice. But I really want to say, what is it? It's 14 problems in the textbook. And they're all these varying degrees. Is that what you got too?
Did you get 11 pi?
Oh, that's gonna reduce.
Okay.
11 pi over 6.
Yes, ma'am. That's what I got.
Okay.
Okay. Well, this is going pretty well.
Yeah, it's going pretty well. You got this.
Thank you.
Is there another one that we should do that seems harder?
We can try number 18 because I just saw a big number. So.
Just saw a big number? Mm-hmm. Oh, yeah, we can. Is that what you got?
Yes, ma'am.
You know what was really nice about a lot of these, like even number 20? is that 18 is the denominator, so that makes it really easy.
I know. They were nice to us.
They were very nice to CUDA software is not always that nice, but it was pretty nice to us on these.
True.
So is there another one? You want me to just keep working them with you?
I guess we could just keep working them out together then because none of them look very difficult. So
Okay. All right.
okay, just for the people if they end up looking back at the link, I don't know.
Oh yeah, true. That's true. For anybody that didn't make it.
I know I use that link a lot.
Oh, really?
Well, I use it like whenever you post it, I use it.
Oh, okay. Oh, well, that's good. Good to know.
So maybe not a lot. That was probably a stretch, but I do use it.
Well, let's see. I'm trying to, I got, 14 pi over 9. Is that what you got?
Well, I was looking for what would reduce, but
I 20 goes into both of them. I got it.
oh, okay, good.
It took me a minute, but I got it.
Yeah, me too. I was like, that's not what I got, and then I realized you were most definitely correct.
Well, I got what happened was I got 10 pi 28 pi over 18, and then I realized I could reduce it again. So I could divide both of those by 2, and so that's how I figured out 20. So on this one, we've got 180 over pi. So that's going to be 12 goes into both of them. So that's going to be negative 15.
Wow, I keep getting like the wrong, I keep not reducing enough. I don't know if that was.
I know. I did that one. I did the same thing on that one, but I was doing it on a separate sheet of paper because I feel that I see this already getting pretty clogged up. So I was like, oh, if somebody does go back to look at the link, they'll be, oh, wow, that's a mess.
Well,
Because 10 goes into both of those. Did you get that?
yes, ma'am, I did.
Okay. And we did number 18, so we've only got one left. 2 left.
Oh, this is one that's already on the unit circle.
Oh, there you go. It was good recognizing. That's good.
I recognized it way late though.
Oh.
I was like, oh, this is familiar.
Yeah, you know what? I was looking at it thinking it was, but then I don't know if the negative threw me off. That's bad. It shouldn't.
Yep, that's what I got.
So
Okay.
there we go. Good job.
Thank you so much.
Not a problem. Not a problem. And the textbook ones are just as easy.
Okay, cool.
So it'll just be good extra practice,
Mm-hmm.
For you
Mm-hmm.
on some of these. Just because when you go back and review these, it's like you got to kind of remember some of that stuff.
Right.
The more we start adding to, right? Fun. Was the video today helpful?
Yes, ma'am. It was pretty good.
Okay, good. All right. Any other questions?
No, ma'am, that's it. Thank you.
Oh, not a problem. Have a great evening.
You too.
Bye-bye.
Bye.
forgot how to do this.
Hey, Campbell. No. Campbell, if you have a question, I can go back through it with you. I've already gone through it a little bit with Adriana, but I can definitely go through it with you if you want me to.
Yes, please.
Okay. Which part do you want me to just start from the worksheet or the conversion? Or start at the top of the worksheet or go through the conversions?
The top of the worksheet is fine.
Okay. All right. On at the very top, drawing an angle with a given measure. When it's negative like that, you're technically going to be going in a clockwise fashion. So, and I've found today that I'm not very good at drawing on this like that. So that would give me 90 degrees. So I'm going to go just a little bit more to give me 100 degrees negative. And then I'm going to draw my line. So that's how you do that.
That's
okay.
it.
Yes, ma'am.
Okay.
And then over on for number 2, obviously from here to here is 90 degrees, and I only want to go 40. So it's about halfway. And, you know, and like I say, it's not going to probably be exact, particularly with me drawing on this. But that's going to be the reference angle for that.
Okay.
All right. And then for 230 degrees, I'm going to go from here to here is 180. And then I know that if I went all the way down to that next line, it would be 270, you know, because it'd be another 90 or, yeah, another 3, what is that? Another 90 degrees. Yeah, 270. I was right. And I'm trying to go to 230. So I'm going to go 50 more degrees. That's just a little bit more than halfway, which, you know, it's not going to be very exact on here. But then I would draw my angle there.
Okay.
Okay. Now, on this next one, there's multiple ways, and I was explaining this earlier, and I don't know how good of a job, you know, I did explaining this. But when you this is a measurement in radians, and when we're thinking about radians on the pie chart or the unit circle, I mean, you know how we were doing, you've got pi over 6, pi over 4, pi over 3 is your first few tick marks in that first quadrant of the unit circle. Well, I know that pi over 18 is going to be way smaller than pi over 6. So, so you can kind of guess, and obviously this is going to be negative. So you're going to be going, once again, just like we did on number 1, you're going to be going clockwise and just a little tiny bit. But if you're trying to get more exact measurement, you could go ahead and do your conversion.
Okay. Which
is the other way that I ended up doing it. And the conversion to get a more exact measurements, because a lot of us just our brains kind of work with degrees a little bit better.
Yeah.
You want to get rid of the radian, so your pi is going to be in the denominator, and you would just cancel out your pi's, and then you're going to cross cancel to kind of simplify before multiply. So you're going to have a negative 10 degrees.
Where did you get the 180 from?
The 180 over pi. That is if like when you're looking at the unit circle, or when you look at 180 degrees on the unit circle, what is the equivalent measurement in radians? Is pi. So your conversion fraction or your conversion proportion is is going to be pi over 180 or 180 over pi, depending upon what you're trying to convert to. Does that make sense? Okay. So just dependent upon it, we'll go over that when we get to the other part of the worksheet.
Okay.
All right. Now, for number 5, 5 pi over 3 is already on the unit circle, and it's something that, you know, obviously Miss Stone and I are having y'all memorize. So that is the equivalent of 300 degrees. So I didn't do any conversions or anything like that because we're kind of hoping that the more we quiz you guys over the unit circle, some of those measurements will come into play. But it was funny earlier, I didn't even recognize, I think it was 11 pi over 6. I didn't, because it's on this worksheet, it's in the negative. And so it didn't, I was like, that kind of looks familiar, but not really.
Yeah.
But you'll see that in a minute. So any questions about 1 through 5?
Isn't 5 different because it's positive?
Yeah. You would go in a counterclockwise fashion. So I'm technically measuring from here. Hang on, let me erase. What you're doing when you're measuring all of these is you're either starting and then you're circling like this, and then I made it all the way around to there. But I still ended up in the same quadrant as I did on number 4, except number 4, I started in a counter or a clockwise fashion. And number 5, I did counterclockwise. I don't know if that makes sense to you.
Yeah.
Okay. And on number 4, I went clockwise.
Okay.
So that's the difference. It's kind of like where the starting point. That's the big difference.
Okay.
And then, so what I did here is I started from this point and went down, as opposed to over here, I started and went this way. Do you see the difference? Okay, cool. On these, find the positive coterminals. Do you remember how to do these? Or no?
Not really.
Okay, that's fine. I'm just going to erase everything I did before so that I can. When you're finding a positive and a negative coterminal angle, you're going to add, what that basically means, what coterminal means, is that I'm going to draw a little unit circle over here to. What that means is, let's say, I guess I'm going to use the 90-degree angle that I have, but it's a negative 90. So I'm going this way on the unit circle. I'm going clockwise. So this is a negative 90 because I started from here and I went this way.
Okay.
All right. What it means when you're finding a positive or a negative coterminal angle is that I want to find a positive coterminal angle. So I'm going to start from here and you make a full circle. So I'm going to add 360. But it's literally the same exact line. So they're coterminal with one another. So the negative 90 degrees plus 360 is going to give me a 270-degree angle. And basically what I'm saying when I say that is that I can draw this angle right here. And it is coterminal, meaning it is the exact same line as a negative 90-degree angle, because this line is still the same.
Okay.
I can also actually go in the same direction, like we started negatively over here. And we went this way.
Yeah.
So if I kept going this way, like that, and did a full circle in the clockwise direction, I would be adding I would be subtracting or adding a negative 360 for a 450. And so that means a positive 270 and a negative 450 are coterminal angles of negative 90.
Okay. We don't have to draw it, right?
No, ma'am. I just was trying to help you understand how we get there and why it is the way it is. Literally, all you have to do is, like on 346, is you would add 360.
Okay.
And then subtract 360. And on 470, for this one, in order to get a negative one, you're going to have to go beyond 470. I mean 360. So you would have to subtract 720. Does that make sense?
Say that again.
Because
that's greater than 360.
Yes, ma'am. Because it's greater than 360. If I just subtracted 360, which I could do for one of my positive angles, actually, if I wanted to, because that's going to give me, what would that give me?
110.
110, yeah. So 110. But I would, in order to get a negative number, because it's asking for a negative coterminal angle, I'd have to subtract 720. Because I have to go beyond that 360. Does that make sense?
Yeah.
Okay, cool.
Does it have to be 720 though?
Yes, because you have, in order for it to be, that's why I was drawing this goofy little thing over here. In order for it to be a full circle, for it to be coterminal, you would have to actually circle it.
Okay.
Does that make sense?
Uh-huh.
As to why? So it has to be multiples of 360.
Okay.
Okay. Now, on number 9, it's asking for radians. So what is the equivalent of 360 degrees in radians? Do you know?
2 pi.
2 pi. Good job. So in order to do these, I've got to add 2 pi.
Okay.
All right. Well, I can't add 2 pi because that's 2 pi over 1. So I have to get a common denominator, which is going to be 8 pi over 4.
Uh-huh.
So that's going to be 11 pi over 4.
Okay.
Is going to be my positive one. And then I'll do the same thing by doing 3 pi over 4. But this time I'm going to subtract 8 pi over 4. Do you understand?
Uh-huh.
Using that same, conversion that I did here, but I'm just doing negative. So that gives me negative 5 pi over 4.
Okay.
So that's my positive and negative coterminal angle measured in radians.
Got it.
Okay?
Yeah.
So the same thing I'm going to do here is I'm just going to go ahead and use if it's okay with you, use that 8 pi over 4 here.
Uh-huh.
And I'm going to get 5 pi over 4 for my positive. And then I'll subtract 8 pi over 4. And then that would give me negative 11 pi over 4.
Okay. Got it.
Okay. Does it make sense?
Yes.
And you feel like you could do it on your own if I let you go?
Is that the rest?
The rest, yeah. I can go back through it if you want me to. This is all conversions. How are you on those? I can erase them and walk through it with you if you would like.
Can you just do like 1 or 2?
Yes, ma'am. And the book work is a total of 14 problems, and they're all pretty much like this. It's just extra practice.
Okay.
I wish I could erase quicker than this, but this is as good as it gets. Okay. All right. So when you're converting, you're going to use the proportion kind of that we discussed a little bit earlier. And you want to make sure that the proportion that you use is that the bottom part is going to be what you want to cross out. Like we know that 13 pi over 9 is a radian measurement. So you're going to use the proportion with 180 degrees over pi. This way, your pi's will cancel out.
Okay.
So then you can cross cancel these, and then you've got 13 times 20, which is 260 degrees. Does that make sense?
So, okay, you cross out the pi, but then wouldn't you cross multiply the 9 and the 180?
I cross cancel those too.
Oh, okay. You just simplified. Oh, okay.
Yeah, because this is technically a multiplication.
Yeah. Okay.
And so you simplify before you multiply. So on this one over here, you've got 165 degree, whoops. And on this one, you're going to want to have your degrees on the bottom and your pi on the top, because you want your degree part to cancel out. Does that make sense? Or no? Okay. So then I think Adriana and I discovered that 15 goes into both of these. And I think 15 goes into 165 11 times, and 15 goes into 180 12 times. So that's 11 pi over 12. So why don't you tell me on number 13, what proportion would I use?
Pi over 180.
Perfect. Pi over 180. And so then 10 goes into both of those. So it gives you 13 pi over 18. And so now you've got a radian measurement.
Okay. I got it.
Okay.
Thank you.
No problem.
Hey, Campbell.
Hey, Mo.
Have a good night.
You too.
All right. Bye-bye.
I saw a video of me, not a video, picture. Told her a video.